Hey, how's it going, geometry kids? Today we are looking at 8.3 trigonometry. You know, a long time ago, so when your parents were in school, this was its own separate class. Now, you get to learn geometry, because guess where it occurs? It's on the ACT now, guys. But I digress. What trig is what it says is all right triangles with the same, they have the same angles are similar. So pretty much what it is you take sine of an angle and you get the ratio of one of the legs to your hypotenuse. So when you look at angle A, which we are for all these ratios, if you look at a calculator, it's going to be that sine of A, whatever it is equal to your opposite over your hypotenuse. The side opposite is the side across the room from A. It doesn't touch it, it's away from it. Okay, opposite, not touching it. Big A is looking at little a, that's opposite. Okay, so it's your opposite over your hypotenuse. Your hypotenuse is always your longest side in a right triangle. It's always your side opposite your 90-degree angle. Okay? So make sure you know it's your opposite over adjacent. And again, the side opposite of A is over here. It's not touching angle A. Your hypotenuse is always your longest side, it's opposite your 90. And the other one we're going to use is called adjacent. Your adjacent is right next to it. Remember, adjacent means next to. Okay, so A's neighbors are the hypotenuse and adjacent, and then opposites across the street. Okay? So your cosine of A, cos, is your adjacent over your hypotenuse. Okay? So my adjacent's here, it's my hypotenuse. And your tan of A, well, that's your opposite over hypotenuse. Okay. What am I saying that? I'm sorry. It's your opposite over your adjacent. Okay. Opposite over adjacent. Now, here's how I remember these, guys. Okay. See this lady up here? Her name's Pocahontas. Copyright issues. So a long time ago, there's an Indian princess named Pocahontas who walked through the woods, and she stubbed her toe on a rock. Ouch! That's the rock. It's a mean, evil rock. And her toe hurt really, really bad. So finally she goes to the witch doctor and goes, "Witch doctor, how can I fix my toe? I just don't know, it hurts so bad." And the witch doctor said, "Soka-toa." Soka-toa. Your sine is opposite over hypotenuse. Your cosine is adjacent over hypotenuse. Your tangent is opposite over adjacent. Okay? That's how I remember it. Soka-toa. Soka-toa. Okay? Get out of my way. So what are the sine, cosine, and tangent ratios for angle G? Well, angle G is right here, right? The first thing I'm going to have to find is my opposite, adjacent, and hypotenuse. Okay? My hypotenuse, well, that's easy. That's my longest side, and it's the side opposite my 90-degree angle. Okay? Next, let's look for our opposite. Now, the opposite is the one that G is looking at. It's on the opposite side of it. And the last one's going to be adjacent, because adjacent's touching G, but it's not the hypotenuse. Okay? So sine of, I'm gonna I'm going to call this angle theta. Theta is a little circle with a line in it. Sine of theta equals, well, let's think about this. SOHCAHTOA. Sine is my opposite over my hypotenuse. In this example, my opposite is 15, right? My hypotenuse, 17. Not too bad. My cosine of theta, cosine is a adjacent over hypotenuse. My adjacent's 8. My hypotenuse is 17. And last we have tan of theta. Well, tangent is your TOA. Not teo, TOA. Which is your opposite over adjacent. My opposite's 15. My adjacent was 8. Okay? That's, you guys just did trig. It's easy peasy lemon squeezy. Okay, this is where things get tricky, guys. On your calculators, I'm going to give you guys a quick tutorial on how to do this tomorrow, how to use your calculator to plug this stuff in. Okay? So bear with me now. Let's find some of these letters. I'm going to blow this up too. We have more room. Okay. For these ones, we want to find the value of W. Okay. You guys see this angle here? Well, we know it's 54 degrees, right? Let's think about what these sides are compared to it using our trig stuff. This W is opposite your 54. It's not touching it. And the 17 is a hypotenuse. You know that because that's our longest side. It's opposite the 90-degree angle. So which one of our trig functions uses an O and an H? Well, let me think about it. SOHCAHTOA. Okay. Which one has an O and an H? Well, sine does. So to set this bad boy up, I say sine of 54, because that's my angle, equals my opposite, which was W, over 17. Now when you plug in sine of 54, you're going to get a number out of your calculator. In fact, do I have a calculator in here? Of course I do. Who do you think this is? So again, we plug in, we make sure we're in degrees, which I'm going to talk about tomorrow. So I go 54 sine. Sine of 54 is 0.80902 equals W over 17. Just a good old-fashioned algebra problem now, isn't it? Times both sides by 17. And we get W is times by 17. And W is 13.75. Okay? Okie dokie. Let's try another one. On this beast, we're looking at this angle. This angle is 28 degrees. And now this one is our opposite, across from it, not touching. This is our hypotenuse, opposite my 90. And over here, it's my adjacent, because it's the side that's touching my angle. That's not my hypotenuse. So I have an opposite and an adjacent. Which one has an O and an A? Well, TOA does. TOA. So we set tan of 28 equals my opposite over my adjacent. Right? Right. Okay. Now, I'm going to give you guys a hint. I usually don't plug my tan until I'm all the way done, but you guys can. So let's do tan 28 for fun. So I hit clear 28 tan of it. We get 0.5317. Please use about 4 decimals. Now, this is where I get into a quandary. What do I do with this W on the bottom? Well, you could multiply both sides by W. These cancel. And then you divide both sides by 0.5317. And you get W equals whatever 1 divided by this is. What's 1 divided by 0.5317? 1.88? Yeah, that sounds about right. Okay. These are tough, aren't they? Okay. Last one we're going to do. Okay. We have a hypotenuse. The side W is touching us, so that's our adjacent. Which one has an A, and an H? Well, cosine does. So we set cosine of 33 equals our adjacent over our hypotenuse. Okay. So again, grab your calculators. 33 cosine of it is 0.83867. Multiply both sides by 4.5, and we get because we gotta get that number out of our denominator. What do we get? We get 3.77 equals our W. Okay. See why we can't use Pythagorean theorem on these? Because we only have one side, right? Okay, I'm gonna have to zoom out somehow. I got a deal for you guys. Since we're running long in our video, do this problem for bonus point. Bonus point. Okay? I'll go over it in class tomorrow. Trig inverses. What that basically means is, think about this. Cosine of an angle gives you a side length over side length, right? But your inverse, that's the ones with the -1 at the top. Take a side length, a side over a side, and it gives you an angle. So if you're looking for an angle, you're going to use your inverse trig functions. If you're looking for a side length, you're going to use your normal functions. Again, I'm going to show you guys on the calculator tomorrow how to do this. Okay, so don't freak yet. Best way to do this is to do an example. Figure at the right, we want to find the measure of y. Okay, so we're looking at y. Well, we know two sides. This side is opposite it. It's not touching it. This side is my adjacent because it is touching it, and it's not the hypotenuse. So let's see, SOHCAHTOA, that's a TOA, right? So I'm going to set my tan of y equals my opposite over adjacent, which in this case my opposite was 100, my adjacent was 41, right? So tan of y equals 100 divided by 41. How do I get rid of tan? Remember, that's a function. So to get rid of it, I take the tan inverse of both sides. Okay? So I end up with y equals tan inverse of 100 over 41. Okay? Which I'm going to plug in my calculator. Oh great, there's no tan inverse button. What is this? Pause. And of course when you plug that in your calculator, which I just did, you get 67.71 degrees, guys. Okay? I suppose you know the lengths of all sides of the right triangle. Doesn't matter which ratio you use. Find the measure of any three angles. No. You have the opposite, adjacent, and hypotenuse, guys. You can use any of the trig functions. Okay? I know this was tricky. Bring your questions. Enjoy.